Welcome to mini lecture 1.2 from chapter 1, Types of Data and Measures. So here we're going to talk about what types of measures we use and why it's important to think about this. In 1946, quite a while ago, Stanley Smith Stevens developed this categorization, NOIR. Now this stands for nominal, ordinal, interval, and ratio. The reason that this is important is because what type of variable we have influences our decisions about how we're going to analyze it, how we're going to visualize it, how we're going to summarize it, and also, we'll see later, what kind of inferential tests and statistics we can do with it. So this forms the foundation of all of our practices throughout the rest of the semester. So nominal data stands for categories, which are mutually exclusive and collectively exhaustive. Nominal comes from the root nom, which means name. And so this means all we can do is name things. We can name these categories something. Mutually exclusive means that if you're in one category, you can't be in another category. So you can only be in one category. And collectively exhaustive means there has to be a category for everybody, even if the leftover category is other. So everybody gets a category. Everybody only gets one category. Some examples are employment, full-time, part-time, unemployed would be 3 categories, a geographic area, urban, rural, suburban. The important thing to note here is that we might put numbers on these. We don't have to in R, for example, but we might. And if we do, the numbers don't mean anything at all. So 1 is only full-time because we labeled it that. Indeed, you can see the full-time, part-time, unemployed go in alphabetical order. And so maybe the numbers are in the same order as alphabetical order. 1 isn't better than 2. It's not an equal distance from 2. It's just a label. We could put the numbers 6, 24, and 103 on these, and it would be just as meaningful. It would be weird, but we could do that because the numbers don't mean anything. Ordinal data is that has some kind of natural rank order or preference. An example of how we might generate this would be to say, please rank the following brands of colleges from 1 to 5. Now we have to tell people 1 in this case is the most preferred and 5 is the least preferred. Okay, hopefully Smith is number 1 for you. Notice that this is different from a rating. So think about like 5-star ratings on something like a movie or something, right? There, 5 means the best, the most stars. And if you have 5, it means you have 1 more than 4. Okay, so that's a rating. The thing about rankings is that we really don't know about the magnitude of differences. Like the difference between your first choice and your second choice could be huge, but then between your second and third and fourth and fourth and fifth, maybe there's not that much difference. Or maybe the choice between 1 and 2 is really hard, and those 2 are close, but those 2 are far away from 3, 4, and 5, right? So the order, definitely we know, that makes sense, but we don't know how far apart these things are, okay? And that's important to keep in mind. Interval and ratio I've put together because we analyze them very similarly. And so the easiest way to think of interval maybe is it has all of the features of the ordinal scales. And by the way, each level of variable has all of the features of the one below it. So ordinal has all the features of nominal. And interval has all the features of ordinal, but also the intervals between points are equal. So like on the 5-point rating scale, right, from 1 to 5, 2 is 1 point more than 1, and 5 is 1 point more than 4. Okay, so the intervals are equal, but there's no natural 0 point there. Um, we could have you rate from 0 to 4, but that doesn't make the 0 natural. It's just where we're going to start the scale. So usually we would think more of 1 to 5. Um, some other examples are shoe sizes and clothing sizes. They do sometimes have a 0, but that's not a natural size because we don't have stick figures, right? That's not a real person. Um, Ratio data has all of the powers of ordinal and interval, but it also has a meaningful absolute 0 or origin point. Okay. And some examples are age. We sort of think of the moment of birth as time 0, and you start accumulating seconds and minutes and days and weeks, and eventually we just stop and we count them in years, right? Income, 0 income has an absolutely meaningful um, denotation, and price. 0 means free. Woohoo! Um, so there, the 0 means something. Um, Years are a tough one because technically there is a 0 year. But because different calendars actually consider the year to be a different number, usually we don't take that as a natural 0. So usually we would think of years as being interval and not ratio. Um, and we also don't usually talk about half years, right? Ratio scales often can take on decimal points. So, if we had year, it's 2026.8, for example. We don't talk about it like that, but that would be more of a ratio kind of idea. Here's an example for the state that we're in. The nominal level for Massachusetts is, for example, its postal designation MA, as opposed to ME, which is Maine, and MN, which is Minnesota. I've lived in a lot of M places. This is MA. Ordinal is the order in which it joined the United States. It was sixth to join. Interval is, again, a year. So when it was admitted to statehood, which was 1788. And a ratio variable could be the total area of the state, which is 10,565 square miles. We talk about the power of the variable types in terms of what we can do with them statistically. So the most powerful is ratio. We can calculate ratios. That's part of where the name came from. The statistics that we use to describe them are the most complex. Interval is slightly less powerful because of that not having a 0 point, although in fact we often analyze it very similarly to ratio. Ordinal data is less powerful still. And we can even analyze ordinal data that's not numerical at all. We'll see that we can have ordinal character, that is name data. And nominal is the least powerful because really what we can do with nominal is we can count how many things fall into a category, and we can talk about percentages. And that's about all you can do with nominal. We also talk about categorical, or some people call it qualitative, versus quantitative, which some people call numeric. So categorical versus numeric, qualitative versus quantitative. Categorical tends to use nominal or ordinal measures. So nominal, like the employment scale that we had, ordinal, like highest level of education completed. And, again, we could put numbers on those, but we don't have to. We can just designate them with the words, like grade school, middle school, high school, etc. Quantitative or numeric data uses numbers and tends to be interval or ratio measures. So again, year, we don't usually say 2026.5. Or ratio, like your weekly paycheck, which might vary depending on, like if you're paid hourly, your number of hours per week would influence your weekly paycheck. For quantitative, we also talk about discrete versus continuous. And discrete only take on whole values. So, for example, the number of arms a creature has: human, starfish, octopus, right? And then continuous is things like your height in centimeters, um, your miles per gallon gas mileage. There's lots and lots and lots of continuous types of variables, including your weekly paycheck, right? Because you don't want people rounding that to your whole dollars, for example. In R, variables are characterized in many ways. Some are numeric, and those can have decimals in R, so ratio or interval. Some are called integers, and those have to be whole numbers, which could be ratio, interval, or ordinal. Some are characters, so those are words, those are text, which tend to be nominal or ordinal. And some are logical, which are like things are true or false, and that's a nominal category, right? They're either one or the other. That's it.